Hi there, I'm Gary.
I'm Siling.
I'm Karen.
I'm Vihong.
I'm Nicholas.
I'm Daniel. I'm Duncan. I'm Tingy.
And we are NDP Group 4! Over the past 12 weeks, we've been working on a robot that can traverse a maze by itself. So, here's our story.
First, we had to build our robot. Now, building a robot from scratch isn't easy. It took us more than 3 hours just to build our very first version. Altogether, we probably built about 9 different versions, each with its own unique features and quirks. And this is the final version. Let's run through all the most important features of our robot. We have an Arduino module at the top, a Raspberry Pi module at the bottom, and 6 infrared sensors all throughout the robot. The Arduino module is responsible for controlling all the hardware. It is actually made up of 3 different layers: a proto shield to control the sensors, a motor driver shield to control the wheels, and an Arduino Uno to connect everything to the Raspberry Pi. The Raspberry Pi is responsible for communications. It connects to the Arduino module via USB, to the Windows PC via Wi-Fi, and to the Nexus 7 tablet via Bluetooth. The robot also features 6 sensors, with 5 at the front and 1 at the back. Altogether, they cover 14 grid squares in 6 different directions. Now, moving on to the software. For the exploration stage, we decided to use the left wall follower algorithm. It is a simple algorithm meant for simple maps, and it works by maintaining a wall on its left side at all times. If there is no wall on its left, it will try to find one and only traverse forward if there is a wall on its left. Using this algorithm, the robot will explore the maze in a clockwise direction, finally returning back to its starting point when it's done. Upon exploration, different aspects of the maze will be assigned different colors. Red denotes an obstacle, blue denotes a viable path, and purple is a virtual wall. Virtual walls are the open spaces around obstacles and walls. We use them to prevent the robot from maneuvering through these areas and risk colliding with an obstacle or going through an opening that's too narrow for it. After exploration, the fastest path is immediately calculated using the A-star algorithm. The fastest path is then generated as a string and sent to the robot via the Raspberry Pi module. Now, our robot can both explore and traverse the fastest path from start to end autonomously. But it still had one problem. It crashed a lot. So, we give it the ability to calibrate its position from the surroundings. It does so by always maintaining a set distance either from a wall or from an obstacle. It also ensures that it is parallel to the grid by taking readings from any 2 sensors facing the same direction. It does this calibration every few steps to ensure that it's always on the right course. We've also added additional features like button control and tilt control using the Nexus 7. And now, the moment of truth.
Okay, last one. Exploration starts. 3, 2, 1, go. Yes. You're not in the leaderboard yet, right?
Okay.
八竿。
刚刚。
哇，真的啊，好